I'm hoping everyone is doing well today. And let's see. Okay, so I'm hoping everyone is doing okay. And let me set this up. So we were talking about inheritance. That's where we kind of left off the other day. So we showed and I demonstrated the fact that there is an object class out there that even when you create a class that is would be considered a superclass, like for example, we went over the idea of here. Let me just grab a car class. We'll call it car. If you guys can see that car, and if we instantiated car, okay, we would wind up with methods. You see how IntelliJ does this? So we're looking at this. It says this dot, and so that dot means it can select from any number of fields and or methods beyond the dot. And of course, the first method it's going to take is it's going to auto select as part of its auto complete, kind of like the old 80. You recall when texting first started in the early, late 90s, early 2000s, there was a lot of predictive text. In my opinion, they kind of went overboard. But there's a lot of predictive text. So the first predictive text is from, see where it says F in as a circle. That means it's from a field that it detects locally. And then from there, if you don't want to, of course, that would be what we would select. But if you don't want that, it will move on to the local method that was defined, which is set text. And presuming that you don't want that, it moves on to clone equals hash code toString and get class. Those are all methods. But the question is, where do we get those methods from? So in this case, if we were creating a superclass car, it would already inherit, once we instantiated car, okay, that would already inherit methods from the object class that is occurring as soon as you download the Java environment, the Java runtime environment. And the same goes for any derived classes from car. So you can imagine the fields that would be for cars, such as make, model, and year, mileage, condition, things like that. And you can imagine if you had a derived class for EVs, you would have many of the same classes from car, except you'd also have miles per charge or range, something to that order. And then for method for car, just for the superclass car, you might have drive, accelerate, brake, test drive, buy, sell, maintain, change oil, that kind of a thing. Now, for electric vehicles or hybrid, you might have all of those methods. You might want to, except, yeah, even change oil. However, with an EV, you would have another method, that the only method that an EV would have not in car might be, like, for example, charge. So because of that, it might be appropriate to have car as your super class, and you'd have EV right here, electric vehicles, as the subclass, or shall I say derived class. And of course, the reason why the EV class is derived from car, because EV inherits everything from car. Okay, now there might be things that EV won't inherit. Okay, you can imagine, but there are things that the EV will actually take a lot of things from the car, like VIN number. An electronic vehicle still does have a VIN number. An electronic vehicle frequently is just a sub model of an existing class. Like, for example, the Mustang. Even the Mustang has an electronic vehicle variant. Okay, which I believe does not even resemble a Mustang. But anyways, so what I'm saying here is that the EVs will also inherit from the object class. So what we're exactly saying is that electronic vehicles ultimately inherit from the car class. So this would be the car class would be a parent class, and EV would be a child class or a derived class. And this child class, as an electronic vehicle, would inherit all this from car, because car also inherits from this object class that exists in Neverland. I guess you could say it always exists, whether or not you have selected it or not. Okay, so anyways, moving on. Let me get out of the drawing tool, and actually, let me just erase this, because if I don't, then I'm just gonna forget. And anyways, let me just erase this. Okay, there we go. Okay, and then we talked about finishing up the text box class. So we said this dot text equals text. And the reason why we say this dot text is so we do not confuse the parameter versus the argument that is being used by the user when he instantiates the class in the main method as it's being done here. Text box 1 equals new text box, and we can see the first improvement right here, which is var text box equals new text box, because text box is redundant with text box. So we have a text box mentioned here and text box mentioned here. And so text box 1 would be the variable. Text box here refers to the type, and this equal sign links text box 1 to the object being created, which is text box. And because we have two text box references right here, we can actually save some, make it look more optimized, I guess you could say, by replacing this first text box reference with the word var for variable. Okay, so now we have text box dot set text, and this is our parameter, to be or not to be. So that is a string, and so to access it and to print it out, we refer to the text right here, because this is a doesn't public void set text. So this set text method right here, it shows that it does not return anything. Okay, so when it doesn't return anything, in order for us to access it and print it, we actually have to say print text box 1 dot text, because dot text refers to the field text right here. Or I should say right here, dot text. Okay, let's look at now the beauty of object creation is we have, let's say, for example, we have one class. We'll call this is our class right here. So in the top part of the class, we have our like instance variables, or shall we say fields, or our attribute data, which defines the attributes of our class. And here I'll just say M for methods. So as I said before, and I know I've said it before, methods define behavior. So the instance variables define what the object is, and the methods define what the object can do. Okay, so the beauty of setting it up like this is when we instantiate the class, we can have any number of objects that are created off the same class, and how your system is able to differentiate these instances, which now are on the heap. Okay, so these are on the heap. All right, and um, these objects are on the heap. However, the variable that is actually the human readable variable that is linking these objects on the heap will be stored in on the stack, as well as all the local variables and the parameters that go into the heap calculation. They are on the stack. So the things that are on the stack, variables like int a equals 3, the a would go on to the stack. Okay? Now, the objects that are created live on the heap, and the way it works is stack information or stack data is short-lived, so it automatically gets deleted when it's no longer being used. Heap objects kind of just stay there a little bit longer, and your system, Java, will actually automatically do garbage collection, which deletes all unused items on the heap. All right, that being said, one of the other aspects of this design that's so beautiful, I guess, one of the ways that it's able to save typing is we only have to write we only have to write one class once. Okay? And we can design our instances to follow and be consistent with that class an unlimited amount of times. So if this class represents a blueprint of a house, we can make an unlimited amount of houses. Okay, so your objects, okay, are going to be defined by whatever location in memory on the heap that the objects reside on. Now we have a connection to that because, for example, we create another object here, text box 2 equals new text box. Now the text box 2, for example, is our link to this second object that's being created. And again, I kind of showed you this the first time the other day, but again, we can see text box to go back to the original text box method to set the text. We can use the method set text and use the parameter text to actually create the text right here, to reference the text in the attributes. Here we have text, and then we can print it. We can say print set text. Okay, now if we go to clear, then the text gets deleted. Okay, it's the same thing here. When we create the second object, we say text box 2 dot set text live at Leeds. This time, Live at Leeds is my favorite Who album, The Who, and I kind of would recommend everyone to listen to Live at Leeds, the original pressing with the only 5 songs on it. But that being said, in this case, we created another object that just prints Live at Leeds. Okay, and then there is the result right there. To be or not to be is printed off in and we can see that it's printed off in to uppercase. So it's all uppercase, and then we have Live at Leeds. So in terms of memory allocation, as I said, objects are kept on the heap, And stack variables contain primitives and short-lived variables. So primitives like int a equals 3, a would live on the stack. Now, you can also use a as a parameter or argument for an object that was created. So in that case, a as an argument would still be stored on the stack, but the object that uses a equals 3 would be stored on the heap. So in terms of memory allocation, text box 1 would be allocated to the stack. The equal sign is the linker. Okay, so what this means is I wish I would have used, let's say, for example, instead of text box 1, we'll just say T capital B1 for the heck of it. Okay, so what this looks like is TB1 is stored stack-wise. Okay, and however, when TB1 uses the new syntax, it constructs the proper way. You might actually say it constructs this new text box. We'll just say TB in as an object like that, and that is the thing that goes onto the heap. And how your I guess you could say compiler is able to track it is it uses its first available memory location to track the text box object. Now, it does its best to predict enough memory allocation, and trust me, it's going to be very expanded because it's going to take the room. It's going to presume that it also needs to keep all of the inherited methods as well from the object class. So you can understand that because reference variables employ inheritance, that the heap allocation would be much larger than just a simple primitive allocation. Okay, so it does its best to predict so that when you say TB2, and you know what, I'm sick of drawing, I'm just going to say TB2. When it says TB2 right here, it does the same thing. It creates another instance on the heap, and it uses the next available. After this is, it takes into account how expanded this can be. So the next available point in memory, it uses that as a reference. Okay. So that's how that works. And I'm gonna delete all this. Okay. So as an example, let's show that objects are stored by reference and not value. Okay, so what we're saying is that if I say something like, let me try to do something like this. If I say something like int a equals 3, if I look up a, it will reveal 3. But that's because a, in this case, is a primitive value. Now, as far as objects stored by reference, let's take a look at what's going on here. This is just a placeholder, hello world. We have var textbox1 equals new textbox. So we're establishing a new variable called textbox1. Now, textbox1 itself will live in the stack, but the fact that it created a new object called textbox, okay, that lives on the heap. Textbox2 is also is creating another text box. But now I'm saying var textbox equals textbox2 and textbox. So now I'm saying that they are all equal. Okay, so what I'm going to do now is I'm going to say set text equals Tommy. And then I'm going to print out, and then you can't see this, but I'm going to print out text box 3, which is equal to Tommy. Okay. I didn't address text box 2 and text box 1 yet. Okay. But the fact that I was able to change text box 3 to Tommy, it also changed text box 1 and text box 2 without me officially declaring it up here. So by modifying one variable, you change the rest of the variables. As you can see right here. Now, we can, in terms of memory deallocation, right? What happens, after you no longer need these objects that have been created, okay? As I said, text box are all stored on all these objects are stored on the heap. They are in fact garbage collected. So variables on the stack are deleted immediately, and text and these objects are deleted eventually on the heap. They are garbage collected. So we are talking about the difference between procedural programming and object-oriented programming. And I was kind of touting the wonderful aspects of OOP, but so far I've been describing what OOP is, but I haven't exactly told you any positive outcome, really, any tangible benefits, of OOP. It's like those people that, those financial gurus that are saying, that are talking about budgeting and things like that. They're like, you may not see the benefit now, but a year from now, 2 years from now, 3 years from now, you're going to see real changes. You're going to see, your savings increase and your 401k increase, yada, 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 right? So far I've been telling you OOP is better, but I haven't been showing you why. So here is an example of where encapsulation, which is a concept of OOP, can help us improve our code. Now, in terms of OOP, we've already talked about one tenet of OOP, and that was inheritance. Another tenet that we can talk about is something called encapsulation. Now let's take a look. Now let's go back to another program we've worked on before, and that is, I was going to say mortgage calculation, but we probably done something similar to this, wage calculation. Now I want everyone to take a minute and examine this code. Just take a second and examine the code, and we'll take a look at it together as a class. Just take a minute to look at the code. Okay, let's take a look. So we have wage calc, and we start off with our main method right here. And we can see that we've declared and initialized base salary as 50,000, extra hours is 10, and then hourly rate as 20. We then call the calculate wage method, and we're using the parameters base salary, which was defined here. We're using extra hours, which was, we're using now these these parameters right here. Okay, they don't have to resemble this. Okay, they could just be X, Y, and Z, and then you could just say X, Y, and Z here, and that does not have to match necessarily, but you actually do have to have all three parameters right here. Okay, so we could really make it more simple, and forgive me, I'm just gonna go back, and let me just go back to my IntelliJ idea right here. And let's see if, let's see, wage calc. Well, never mind. Forget I don't want to reveal the next step. So I just wanted to say, if you had X, Y, and Z, you could just put X, Y, and Z here, and you could just leave this alone because these are just placeholders. But nevertheless, these are three placeholders. And right now, and then we go to we then define the calculate wage method right here, because this obviously is referring to the method, and it is going to return an int. And we're just, I know when in terms of wage, it should be in a double or float, but we just want to keep things simple. Just call it an int. And then we're going to return, the reason why we're returning an int is because we're returning base salary plus extra hours multiplied by hourly rate. So it's a good way for you to calculate your wage if in fact you make a salary, because most of us know that if you make a salary, generally you could get damaged. Your wages could get damaged if you were hourly, now your salary, because now you're given, let's say you're working 20 hours of overtime, and people that are salary paid don't get any overtime. But here, in this case, you are getting a base salary and you're getting hourly rate for the extra hours. That being said, return base salary plus extra hours times hourly rate. So I'm just explaining to you this code. Can somebody tell me how they could possibly, somebody tell me any issues with this code? Like, how do you think we can make it better? How do you think we could improve this code?
I mean, the thing that kind of comes to mind for me is just kind of like where like wages are being stored. We're not really like attaching the wages to anything or like anyone. We're just kind of calculating them there. So maybe it would be good to like create
Okay.
like a person or like worker class or something to store the information somewhere meaningful.
Yeah. That's good. That's good. Well, for one thing, the main method has several lines of code. Okay. However, the calculate wage method only has one. So we have 1, 2, 3, 4, 5, and the calc wage method literally only has one line, but yet it appears like it has more. I kind of designed it like this so it could seem like it's even, but it's really not, right? We simply created a method and called this method within the main method. That's all we did. We created a method and we called it. Just because we use a class does not imply, let alone mean that we're using OOP concepts. So even though we're using a class, because that's the way Java wants us to do things, that everything has a class. But inside this one class, this is still only one single class. But that doesn't mean, because we're using a class, that doesn't necessarily mean we're using, OOP concepts. This actually is an example of procedural programming. Okay, think of it. It's basically method-based. Okay, the heart of it is in the method. So, in other words, there is a separation between the variables that are declared in the main and the variables being calculated in calc wage. It's like they're on separate islands. So really, the first OOP concept that we're going to actually employ, because although I have talked about inheritance before, the first OOP concept that we're going to deploy is something called encapsulation. Okay? So we have talked about inheritance, and maybe we've touched on polymorphism, but encapsulation really is one of the biggest tenets of, or when I say tenets, I'm going to say beliefs, systems, or attributes, if you will, of OOP or object-oriented programming. So the idea of encapsulation, what is encapsulation? It's when we bundle the data and methods so that they are a single unit. So how does this affect this? How can we encapsulate all this, and why would we even want to? So the goal of encapsulation is making the data and methods into a single unit, like a capsule, or as they say, class. Okay? So one improvement or one observation one could get from this is taking a look at this. Okay? That's a whole lot of parameters right there. Now, before you say anything, you're like, well, there's only 3. I mean, that's true, but this is the simplest of the simple programs that there could possibly be. There will be instances, or there will be contexts, I should say, that if you work for a tax accountant or something and you want to build some tax tables, you might wind up with many, many, many more parameters. So why not just put everything in one class? Okay, so instead of this is the before, I guess you could say. And let me just put this, let me just do this. This is the before. And then now what we're going to do, we're going to create a new class called employee. So this employee is this type class. And we can isolate the wage calculation, take everything from the main, and we can isolate everything in the employee class. So now, with everything inside the employee class, we've encapsulated everything. What happened to the parameters? There's no need to recall these redundant parameters, because everything is in the same class. Okay? And so we can even optimize it even further because base salary and hourly rate tend to be set and fixed. All you need to do is calculate the wage and using the amount of extra hours as your argument. So, we have, now wait a second. We have new employee, but employee is in red right here. Why is there an error? Because we needed to add employee class to the wage calc package right here. Okay, so you need to type out package space com dot wage calc, because when we go to the main class, if I can ever find main class right here, I guess there is no main class, so my apologies. But when we go to the main class right here, up here, the main class and the calc wage class have to have the same package right there. So this new employee was in red prior to me typing package com.wagecalc. So all of your classes have to be in the same package. That's how your compiler knows that these different classes in these tabs are the same. So take a look at this one right here. This is wage calc, and this is the main method, and the name of this of the program is wagecalc.java, because of course whatever class contains the main method, the overall program has to have that name, wagecalc. Now, wagecalc will be part of the package called wagecalc, and of course the syntax is com.wagecalc. So it's like inverse domain name. But what I'm saying here is, to avoid errors, you want to make sure the classes that the main class, which in this case is wagecalc, all the classes that wagecalc will reference, they have to be in the same package as the main class. So if I just remove this package wage class, watch what happens. See all that? All that turns red because it doesn't know what employee is, because you took employee out of the wage calc package that contains the main method. Okay? So we have to, let me just remove that, and now we can see that everything is back to normal. So this is our new main method. We have employee.12 base salary is this. Hourly rate is this. And 12 calc wage and amount of extra hours is 10. And here is the ultimate optimized result here. Here's the main class is here, and the employee class is here. So the idea is, by placing the calculation method and the variables in the same class, as you can see here, we've encapsulated the data and method that uses the data. Okay, so some of you are like, well, wait a second, how did this improve our code? Well, if you take a look back here, we can see that we're avoiding all these ugly parameters that are defined, and we are combining these previously disparate pieces of information into one data structure, which is the employee class. Okay? So I'm hoping that everyone can see how this is optimized. Okay? All right, that is it for today. I just wanted to finish off the slides from the other class. Just be prepared for more homework this week, which will be uploaded in the next couple days. Did anybody have any